we will start our first technical session of today's conference. And so I invite Professor Dr. Noor Mohammed Khan to chair this session.
Thank you, Ms. John. We are about 20-25 minutes behind the schedule. I'm sorry for this delay. Our today first technical session is focused on hydraulics related researches, and the first keynote speaker of this session is engineer Fazal Rehman Kashif. He is chief engineer NESPAK, and I am happy that he has joined this conference on our request. And I also want to tell him that his a senior colleague and engineer Tariq Altaf is also with us physically in this room. So he is saying hello to you. Engineer Fazal Rehman Kashif is currently working as chief engineer at NESPAK. He did his MSc in hydropower engineering from Center of Excellence in 2003. He worked as Deputy Director, Federal Flood Commission, Islamabad, and he worked as Junior Engineer in Irrigation Department, Bahawalnagar. He has overall 22 years of work experience on water-related projects, and he was also Secretary of International Commission on Irrigation and Drainage for Working Group on Sustainable Drainage. I have been informed that he is working on Hill Torrents project also. Engineer Kashif, you are welcome to conference. Please, in 15 to 20 minutes, tell us about your recent work. I will also request all the presenters, please listen to the time calls and please try to conclude within the allocated time. Fazal Karim Saab, your voice is muted at the moment. Your camera is visible, but your mic is muted. No voice up till now. Although mic is not muted, but I think your mic has problem. So please use some other mic. Mic is unmuted. Use some other mic. Maybe mic of the laptop or some other.
Sir, you are stop sharing.
Now your screen is visible.
Okay, sir. Now you are listening my voice, sir?
Yes, now I can get your voice. Please go ahead.
Okay, sir. Sir, today, thank you very much, Center of Excellence, for giving me an opportunity to share my experience regarding the sustainable water resources management, which I have implemented in NESPAK and doing the number of water resources planning project and their sustainability, how to ensure, how to we will incorporate in our the feasibilities. So basically, sir, I want to show that what is the sustainability in regarding the planning of any project. What is sustainable water resources management (SWRM)? So it is basically the as you for as a just knowledge review, as you are all aware that it is meets the current ecological, social, and economic need without compromising the ability to meet those needs in future. Basically, sustainability is that we can assess our water resources in a way that we can plan our project keeping in view the social components, environment components, and not affecting other aspects of the in future. So it is the basically approach, sustainable water resources management approach, which is now emerging, and it is the requirement of the time. And you can also see in the importance of what is the importance of that. As we are all aware that Pakistan is heading towards water shortage country in upcoming year. As you are watching, per capita water availability in 1951 was 5,260 cubic meter, which ultimately to 2016 in 1,000 cubic meter, and further it may be likely drop in 860 meter cube in 2025. So they have the reason as we are facing the climate change aspect, and other the thing in the population is increasing remarkably. Our cities are growing up, so we will there is now transition from water stressed to water scarce country. So that's why the topic sustainable water resources management is so important that we should highlight it, and being as a NESPAK, and we are doing to implement this sustainability in all our projects, and accordingly we are contributing in our the feasibilities and the PC1s which we are generating, and it is also a national water policy which is approved in 2018, which is the last, I think, which all provinces are remarkably approved it. So in this water policy, it is an essential part of sustainable water resources management. It has a section which is dealing by using the integrated water resources management so that it can be applied and implemented in each project. So it is basically the map which are we showing by a statistic, the global research firm which I'm showing. Pakistan is coming in water will stress country. So it is basically the graphical presentation. So now basic concept for SWRM, how we apply it. In it, we can use integrated water resources management approach to integrating the various components which are essential part for planning. Then after planning, then it will be executed, and then how it will be made sustainable by using the proper management. And basic purpose for sustainability to saving the precious. You can water, irrigation water, and from rain is coming, the all water which we will save and use its optimum efficiency to meet the future demand of agriculture sector and also the domestic. And it is basically you can say the 4 parts of our the system. In the canal water, we are getting for supply, lake reservoir capacity, lakes are there. Effective drainage is also the part in which we will make to drain out the flood water to not hitting any prone areas, and we will safely pass the floods to in the rivers, and then drainage surplus we will count and keep it part of our sustainable water resource management. Then utilization of rainwater. So it is basically the integrating of all these parameters which are the water bodies in our project area. So which we have done in the components. Basically, we have done a project of for Karachi for doing a integrated water resources management of the Kinjar Lake by focusing on Kinjar Lake, in which we have the parameter, which we have all the basic components of any sustainable water resources management, and then implementation. What is water availability, as both in Rabi and Kharif, canal system was there in distribution system, identification of depression and soil reservoir and the thing, and the other assessment of water demand, agricultural pattern, drainage pattern, groundwater, climate change, social environment, water quality, and seawater erosion. I took the part of this presentation due to all the components which are essential for any integrated water resources management. So that's why I select Kinjar Lake, which is has all the effects, and we have done this project. Sir, ये map नहीं आ रहे यार. Sir, excuse me, maps. Sir, you are getting the maps in your presentation?
जी सर, हमें आपकी स्क्रीन भी और आपके कैमरा दोनों नजर आ रहे हैं. प्लीज गो अहेड. आप
लेकिन सर वो आपको ये
वहाँ पे शायद
डिस्प्ले नहीं हो रहे.
आपके जिस आपकी स्लाइड में मैप्स हैं वो वाइड नजर आ रही है, मे बी रेजोल्यूशन का प्रॉब्लम है। अब इससे नेक्स्ट वाली में हमें मैप नजर आ रहा है।
you're getting, sir? Now, sir, ये मैप
जी सर, ये नजर आ रहा है। जी सर, प्रोजेक्ट मैप नजर आ रहा है।
जी जी सर, ये बेसिकली that is the area of which my cursor is going. In that, it is the Hyderabad. It is a case study, basically the KB feeder project, which offtake from the right of the Kotri barrage, and it is the going through KB feeder canal, which is going, and it is the Kinjar Lake, and it is the lake of Hadaro Halaji Lake. It is the three lakes. So basically, and it is here is the Karachi. So it is a complete project which we have integrated with all the components, a river from the Kotri barrage, a link canal of 9,000 capacity, then a lake, then these two lakes, then complete distribution system of right side of the Kotri, and then drainage area, then sea water intrusion here, which are seeing the sea there, which is hitting toward, and the other is a Karachi project. So basically, it is a waterlogged area which have been creating due to the seawater intrusion, and it is the areas day by day getting the waterlogged. It has the reason. I will share you again the scene. So basically, sir, it is our for simplicity, it is our line diagram. In it, for simplicity to understand the people, to understand, see, Kotri barrage, KB feeder is the main artery which are supplying the water from Kotri to the Kinjar Lake, and to the right side of Kotri agriculture land, about 6,80,000 acre, and Karachi to Kinjar Gujo Canal. So it is our basically the project area in which we have available water resources are there, which we have integrated it with various hydraulic design approach and come out with extension of lakes. So it is the further refinement of that area in which we have network of arteries of distribution system of canal, of right side of Kaldi Bazaar feeder system complete. Then now, what is the situation analysis? What are happening there? Okay, how much water is available? Now we basically are planning for the Karachi for 2050 for using the sustainable supply to the Karachi. Karachi have only a single source, had two sources for water supply, one from Indus and then other from Hub. Hub is not a permanent source for water supply. Indus is a permanent source. So we have planned in the first water availability. Water is available, as Shahid Sahab mentioned, during Kharif. Water is available in Kotri. The hydrograph which we have analyzed the data last 20 years, it is clearly showing that water is available. Now the system, we have to identify the depressions to store it, to enhance the capacity of the Kinjar Lake, so that we can store the surplus water from 15 June to September. Monsoon season is on, and we can store it. So and make it a sustainable use to Karachi in 2050. So it's water availability. Then how water is available. Excuse me, sir. Sir, it is basically the flow pattern which we have the data took from the KB feeder, analyze it of last. What is the flow pattern of KB feeder, which is the main artery from Kotri to Kinjar Lake, supplying the water. It is a complete geography of that canal. It is the Kinjar Lake flows, how it is operating. The lake has achieved maximum level of 54 feet, never been depleted below 43. Lake operation shows the lake has been filled twice a year, once at the end flood season in September. And it is basically the water demand for 2050, which we needed water for Karachi in 2050. It is about 2,778 MGD, which is about 5,000 cubic water will be required in 2050, about the population which will be 57 5 crore is the population which will be the in 2050. So, and the other our parameter which we will very important, agriculture demand. Now, what if the existing prevailing condition is there? You can see that at this we are also facing the shortage for the crop water requirement, which is required 770,000 is the requirement of our discharge, and we are also facing the shortage in the agriculture demand. We are not meeting. It is the peak requirement in July. So both are facing the shortages in agriculture and also Karachi city. And now how we analyze it by using the integrated water resources management approach. What are going there? We use the GIS remote sensing techniques and the other hydraulic modeling tools, GeoStudio for seepage, mod flow for seawater intrusion, groundwater and drainage system for other parameters. It is the basically the waterlogged area at the right side of the area of the Kotri, in which the seepage has some reason due to the seepage from unlined pillar, seepage from lake. Sea intrusion is there because Thata and Badin, as you know, is a low-lying area in which sea is approaching towards, and there is a crop distribution system, and there are the fish ponds are there. High delta crops is going there. Non-contagious existing drainage system is there, and also the tides are coming, which are making the outfall of the drainage non-modular. So it is the combination which are generating the waterlogged area. Now we are analyzed by using the GIS remote sensing techniques by temporal analysis.
काशिफ साहब आपकी स्लाइड्स मूव नहीं कर रही, आप दोबारा से शेयर कर सकते हैं अपनी स्लाइड्स? आप इस वक्त स्टक हैं 11 नंबर स्लाइड पे।
अच्छा जी, राइट सर, 11 नंबर स्लाइड पे कौन सी यार? सरारी
सर दोबारा से अनशेयर करके शेयर करेंगे ना तो फिर शायद ठीक हो जाए।
अच्छा आना यार, एक मिनट
अनशेयर करें और फिर शेयर करें।
आ जाए यार, एक मिनट दोबारा करना इसको शेयर दोबारा करते हैं। Sir, are you getting, sir?
जी सर, now it is on slide number 18.
18.
Okay.
19, sir, 19.
Yes, sir.
Sir, you're getting?
जी sir, go ahead, please.
Go ahead, sir. Sir. So, sir, basically, now we come up with the issues. What are the issues? What are our problem for to feed the Karachi in 2050 and to meet the irrigation water requirement for the right side of Thata command area, which is more than 7 lakh acres. So, how we analyze the problem, and the water logging is there. It is the complex issues are there. How we use by using then integrated them in this. Very hello here. It is the reason for water logging is that it is the basically low-lying area. Sea is there. Thata is very low-lying area. Depression are there. So the distribution system is irrigating the typical flood irrigation. High delta crops are going there, and the drainage system which are not properly working due to the tidal behavior of the sea. So these all are contributing. The area are becoming waterlogged in that area, and now we have done then its temporal analysis that what are happening there by using the advanced survey and remote sensing by using the temporal analysis, in which we downloaded the image, and we have in it we have come our the slides of by downloading the image, then applying the necessary check to estimate the what are happening there by to history. In 1972, we download the image and highlight the area on reflectance base. What was the water logging in that area? And then 1972, you can see. Then we have come with 1988. That area you can see the water logging is increasing. It is reflectance based basically. 2000 area you can see. Now we come 2013. Now area of water logging is becoming more. And it is 2019. We were involved in that project till 2019. So we did our temporal analysis till 2019. Then we did the ground truthing, and it is the groundwater elevation map which we have. WAPDA has their piezometer in that area, which we took the post-monsoon, pre-monsoon to calibrate our the findings of the temporal analysis by reflectance base. We have took the 10 years data and it's analyzed to know the what are the groundwater, how it is going towards sea, base flow is going or not there. And it is our the very result. You can see in 1972, waterlogged area is very rare. As it go ahead, the blocks are changing, crop area is decreasing, and in 2019, it has been, you can say, reverse. The waterlogging is more. And now, and it is very interesting result you can see from here. And it we have also verified it from our agronomist for taking the from revenue department. They are also showing the same result. And now, what are now we have in the view how what are going there in that area? How are we are getting more water are plugging in that area, in going that area, and accordingly we are in view to calculate drainage surplus. What are the drainage surplus? And it is our the calculation in which we have what are the resources there, Halaji, Hadiaro Lake, 3 lakes, what are their evaporation, what are their groundwater recharge. Then the most interesting part of that study is that the area, lot of area has been converted into the fish ponds because the people are now becoming waterlogged. So they took their agricultural land into the fish pond, which are also contributing. And it is 44,212 acres. So it also contributing the groundwater. So the things are becoming worse and worsening. And most interesting is that how we calculate with all things what are they the water is going that area. Summary of groundwater is coming. It is 360 cubic, which are going that area from the irrigation canal, lakes, fish pond, from precipitation with data PMD, Tandojam, which we took the data from other agencies and analyzed it. When it come and the result come where in it area, and you can see here it is the number of drainage are there, network of drainage, Godawari drain, number of drain. Then in spite of all this, we are you can see that we are you can see number of drainage network is there. Then why the area of water logging is increasing? It is very alarming. So then we also come up with a result that you're getting. So,
Kashif, please again share your slides. We are stuck on slide number 21.
Slide number 21. Okay, okay, sir.
And please conclude in 3-4 minutes, please.
Right, sir. Right, sir. 21. Oh. 21 की थे.
You will have to unshare and then share again.
Right, sir. Sir, you are getting? Sir, you are getting?
Not yet. It is blank screen at the moment. Maybe your pictures are very heavy. So
okay.
maybe
Then, sir,
go
I
to
come
some
up
text
with
slide.
so you are getting, sir? No?
At least my computer is getting blank screen.
Stop sharing. Okay. Oh, sir, I try once again.
किसी टेक्स्ट वाली स्लाइड पे जाके फिर आगे
जी सर जी आगे जी तो सर यू आर इन slide number 27 sir. So it is 27 you are getting?
Okay. Please go ahead. I think there is some problem. I am not getting it. Go ahead, please.
Okay. So, okay, sir. That is our the conclusion of waterlogged area after temporal analysis, in which you can see in 1972 the right side of the Kotri command area is crop area is more, and in 2019 the crop area is very less. There are the reason they are growing the more high delta crop, sugarcane is there, rice is there, and they are going to convert their area into the fish pond area, which we have also proved from the our satellite image through temporal analysis on reflectance base. Yellow area is about 44,212 acre is becoming the fish pond area, in which area is contributing to the water logging. Then we have come up with our drainage surplus. What is the drainage surplus in that area? Having the drainage system in which we have a network of drainage, then why we are the things are going worse, the area is going to be waterlogged. So what are the reasons? So we come up with that the total discharge which we have come up with, the infrastructure is there, drainage, irrigation canal, and the capacity of the irrigation canal which is coming is almost matching. Then it means we need more any activity to drain out. So we come up that tides are basically the issue which are not proper are going for drain to get the modular condition at the outfall condition. It need to be implemented. And the other most important factor is that the you can see the sea level, which is very adjacent to that area. You can see in that if water table below the sea, then sea will intrude. So it is the basic diagram we need to be understand. If tide is more, the water go into the drain, which are also in low to the sea level. So it need to be, we have come up with that outfall conditions of any main drain which coming to the sea need to be improved. Their working head should be improved. So it has been implemented. Now it is how we can come up with the seawater intrusion. You can see the arteries. Where there are arteries, their irrigation system is there. You can see sea is not approaching towards the land. So now we concluded it. Okay, if there is any irrigation water is going, so we cannot line that distributary. It is our another finding to check the seawater intrusion. Fresh water will go there through in shape of the distribution system, which clearly shown by the distribution system from the image. And the seawater intrusion, basically you can see from 1990 is oscillation process. When there is some rainwater is coming, the sea is back, and when there is a drought in the area, where areas areas less water is going, the sea is approaching towards the river. So it is not an alarming situation. And it is our another area to how the sea is going at which rate towards the Tata area to the Badin area, sea water region. So it is our another result in 1990, 1995, 2000, 2010, 2015, 2016. So area. Now, after doing the analysis of all the parameters of all the factors for introducing a further extension of lake to meet the Karachi demand. So can we afford to create another water body adjacent Kinjar Lake so that the area will not be not added up further waterlogged if we store another water body to extend the Kinjar Lake. So then we come up that line the distribution system of KB feeder system and save the water that will also be used to the for sustainable supply to the Karachi, which is about 676 cubic the cubic water will be saved. Then it is the our basically the extension of lake. You can see these it is the Kinjar Lake. If you if it is you can see if it is coming. I think it is when I stop. It is once again we lose. Stop sharing. I stop the sharing. Then again I try to share it.
It was visible over here. Okay, can we conclude, Kashif Saab?
Sir, yes, sir. Sir, actually, yes, I conclude. Yeah. Sir, by in that area, which our basically the purpose is that to sustainable supply to the Karachi and plus to meet the shortages of right side of the Kotri Command KB feeder area. So we come up with that the Kinjar Lake should be extended as per the depressions are there to interlink it with, so that we can make a storage water from for Karachi. The existing capacity of the Kinjar Lake 0.66 MAF, with including the dead storage, to 0.44 MAF is the live storage. So by integrating the other lake, Halaji and Hadyaro, we can create another lake, and we will reach that through interlinking them. In that, if you can see the image in which you have seen, we need to reach near Gharo by interlinking them from Kinjar Lake, about 150 kilometer from the Karachi. You can see by interlinking them, only by joining their topo and their by interconnecting all, we can save the losses and we can reach the Karachi. And by estimating the other aspect of water logging, we can come up with the issue is that 300 cubic will be more added to the system. So we will propose a tube well along that area, so that it will be take the seepage along the Kinjar Lake, and it will further be used for the Karachi for the supply. And then is basically the conclusion of of our way forward, that climate change, rapid and unregulated urbanization pushing into the category of water stress countries, our countries which coming. Climate change is causing faster melting at high altitude places on the which is Indus Basin system dependent, and also raising the sea level. Climate change threatening the in terms of increasing frequency and intensity of the flood, prolonged droughts, and frightening possibility of melting of the human ice cap. So basically, the idea of is that sustainable for any water resource management, the concept more crop per drop. Basically, it should be the slogan, which is also reflected in our national water policy. More crop, more per drop, use the efficient method, and plus other our finding to please rationalize the canal water allowance, which is the main reason for that area. But मावरत के साथ कि जो हमारे सिंध वाले भाई हैं वो कहते हैं कि वाटर अलाउंस जो हमारा शेयर है ये हम इसको कम नहीं कर सकते. इस एरिया में जो वाटर लॉगिंग का इशू है यहाँ पे वाटर लॉग 15 के करीब है, which is to give the more productivity, it is declining the area. So and high delta crop is there. तो और इसी यहीं से कराची को पानी सप्लाई होता है. And other जो flood water management which we have done, the from जो पानी 15 जुलाई 15 जून से लेकर 15 सितंबर तक जो पानी आएगा वो पानी हम किंजर लेक को स्टोर को एक्सटेंशन दे के जो तकरीबन कराची के पास पहुंच जाती है बाय ओनली इंटरकनेक्टिंग देम विद मिनिमम एफर्ट. जो आपने सिर्फ यूनिट करनी है, डिपेंड करना है और आप पानी वहां तक ले जाते हैं, उससे आपके लॉसेस कम होंगे और कराची को 2050 की प्लानिंग भी कर सकते हैं. सर इट्स ऑल ओवर. सर मैं आपको वीडियो दिखाना चाहता हूं, अगर मैं कामयाब हो जाऊं. 2 मिनट की वीडियो है सर. जरा
मेरे ख्याल में वो लिंक और नेटवर्क का जो है ना इशू है, वी आर वर्किंग ऑन PTCL नॉट ऑन लैन, सो पिक्चर्स और वीडियोस का प्रॉब्लम चल रहा है.
चलिए सर. तो सर इट्स
थैंक यू वेरी मच काशिफ साहब फॉर स्पेयरिंग योर टाइम एंड taking us to Delta area and the project of resolving the issues of Delta area and especially the Karachi water supply problems. Thanks a lot for your comprehensive presentation related to water resources management.